This meeting is being recorded.
Okay, so networking is all about connecting different systems, whether it could be in the same location or in different locations, inside a house or inside a company, in a small office space. The core area of networking is how they intercommunicate when we wanted to communicate between devices. That is all about networking. There are a lot of components that can make network to communicate. It could be between the devices inside the same office, or it could be devices in different office spaces, right? So there are different protocols to make it happen. Overall, the course is designed to make you guys understand the fundamentals of networking and what are those protocols and how each protocol is defined, and how do we use this information in the real world scenarios, and what is the major responsibilities of a network engineer. So before we understand about the core concepts, let me give you an idea of what a network engineer will do in the real-time world. So let's take a use case of a corporate network. There are 100 employees sitting in the office, and they all wanted to contact their data center or their headquarter office. Let's say the headquarters is in Chicago and they are sitting in somewhere in Virginia. Those 100 employees sitting in a branch location want to communicate with their headquarters in Chicago, right? So here we have a small office space, 100 employees. And now these employees should be connecting to their data center or their headquarters, HQ, okay? And now these employees will have a internet link for their office, right? So they have an internet link. And then this headquarters will also have an internet link, right? So now these employees should be able to communicate from this office to the headquarters over a dedicated tunnel. Because the internet is not secure, there should be a tunnel between the office space and the headquarters. When I mean a tunnel, it's a logical connection between the office in the remote location to the headquarters. There should be a VPN tunnel, which is secure over the internet. So as a network engineer, my responsibility will be building this tunnel, or if there is any issues with employees not able to communicate with the headquarters, if there is any issue, if there is any breakage in the connection, I have to fix it. So I need to deploy the tunnel, or I have to fix any issues in the tunnel, or if there's any issue in the communication between this employee to this headquarter location, I have to find out why the issue is. So that is one use case. I mean, one type of use case. Let's pick another use case. Let's say you are sitting in your house and you are trying to go to you ordered a internet connection to your house. So a technician will come and they will install a router in your house, and that router will be connected to a site modem, a bigger modem, and that will be connected to the internet. So let's say in your community there are 50 houses. Every house will have a router, and they all will be matching to the site modem. So as a network engineer, my responsibility is to make sure this site modem works fine. So if all of the houses in the community lose the internet, they will escalate the issue, right? So as an engineer, we have to make sure the site modem is working fine and all these houses are getting the internet connection. There is no issue. So we have to be responsible for maintaining this site modem. That could be one use case. Or another use case would be validating. Let me clear this. Another use case is, let's say we have let's say this is a remote location again. And then from this remote location, I have a user sitting in his house. He's working from home. Okay. So from here, this user is trying to connect to the corporate office. Because he's working from home, we have to make sure there is a logical connection from his laptop to the corporate office. Otherwise, he cannot work and complete the needed work in the office, right? So there should be a connection between his laptop. It's a work laptop. And then there is a corp office. So this work laptop should be able to be on the VPN. And then this work laptop should be connecting to the corp office over the internet. Again, the internet connection will be there, but this time this is not per multiple users. We don't have like 50 users to form a VPN tunnel between site to site. But here there is a remote work laptop. The end user will be having a thin client on his machine, like a software, and this software should be able to build a VPN tunnel to the corporate office router. So if there's any issue, I will be making sure this router will be able to communicate with the corporate office. So as a network engineer, if there's any issue on his laptop on the VPN configuration or on the router configuration, I should be able to fix it. So that could be one use case. Or let's say these are all VPN use cases, right? Now, let's say there are two laptops in the same, or two PCs in the same company. Okay. So let's say there is a corporate company, there is a PC1 and PC2. The PC1 should be able to communicate with the PC2. Okay, they should be able to communicate with the PC2. Now, as a network engineer, I should be able to make them communicate between them inside the same location. That is called LAN, local area network. So inside the same location, if two devices want to communicate between them, as a network engineer, we should be able to, cable them properly through a network device like a switch or router, and we should be able to make them communicate. That is called local area network. So what is LAN? LAN is nothing but interconnection of systems inside the same geographical location. That is called LAN. Let's say we have PCs in one LAN and we have another LAN, which is like another systems in different location. This is one more LAN. And if we wanted to make this LAN communicate with other LAN, that can be done with WAN connection, which is wide area network. So when we are making location 1 to communicate with location 2, there will be a WAN link between them. As a network engineer, our responsibility is to make the WAN work and also the LAN work. Okay. So the agenda of this course is to make you guys understand how the LAN connections work, how the WAN connections work, how do we dynamically fail the networks, meaning like, let's say there is a network issue on one of the path of the network. How do we dynamically fail over that without manual configuration? The users should not be able to face any issues with the network, right? Let's say, you are a customer using Netflix and you want to watch a movie. Whenever you open Netflix, you expect the Netflix servers to be up and running. But when you open Netflix and if it says like Netflix is down, you will not be a happy customer because we are not able to provide services to you as per your need. So for that, networking is important. because Netflix services always have to be up and running. So as a network engineer, it is our responsibility to make sure that our servers are reachable for the customers all over the world. I just gave Netflix as an example. It can be Facebook, it can be YouTube, it can be file sharing, it can be reaching out something over the internet. So anything is involved connecting, communicating, it all requires networking. Not even that. Think about like making a video call on your WhatsApp or sending a text message in WhatsApp. This all needs networking, the intercommunication. The mode of transportation changes, but the concept stays the same. Underlying concept stays the same. The protocols may be a little different based on the flavor of devices that you use, but the fundamentals does not change. Are you guys following me? What I'm trying to say here and what is the purpose of this course?
Yes, sir.
Okay. So now let's see our agenda of this course. Let's see the appendix of what we plan for 1 month, and then we'll talk on a high level of each topic. What is what? 1 second. So day 2 is about OSI model and the TCP IP model, meaning like when we are troubleshooting a network, let's say this is network A and this is network B. If network A user wants to communicate with the network B, let's say they were not able to send a file between this network to this network. They wanted to share a text file, but they are not able to communicate. So to troubleshoot the issue, there should be a step-by-step procedure. What can be the issue? So to make the life of engineer easy, they bring up a model called OSI layer model that will help you to troubleshoot the issue by separating a big issue into smaller issues. For example, there is a concept called dividing and conquering. When you have a big issue, if you don't know where to start, you have to divide them into multiple smaller parts and then fix the small parts that will give you a bigger picture. It's like solving a big puzzle by solving small parts at a time and then solving the bigger puzzle. So that's what the OSI layer model and TCP model is known for and how they are used. And day 3, we will talk about IP addressing and subnetting. In this IP addressing and subnetting, it is all about how we wanted to separate the network. Let's say we have 100 users, and in those 100 users, we wanted to separate them into different teams, like 5 people in HR, 5 people in marketing, 5 people in education services, 5 people in IT services, like that. There are different departments. We will separate the users into different sub networks. So this is all part of one network, but based on the departments, we will separate them into different sub networks, and that can be done with the IP addressing and subnetting. So subnetting is nothing but sub networks. So you have a big network, but inside that, let's say you are owning a company. Inside your company, you have different employees. Some of them are like accounting, some of them are like marketing, some of them are like IT, some of them are like business side. So you are separating them into different sub networks based on their business requirement or business need. You are separating them. So in that case, we will be using subnetting to make sure one subnet is different from the others, so that we can have the security in play. So a marketing user cannot send or upload the files to the HR team. HR team is separate than other teams because they carry the sensitive data like employee pay rate, all of that. So subnetting works in terms of separating the users. Day 4, we will continue the subnetting practice. How do we do that? How do we calculate the users? There is a formula to calculate the users. What is a subnet mask? How many hosts can be calculated? We'll discuss about that on the day 4. Day 5, we'll talk about the routing fundamentals. When I mean routing, routing is nothing but communicating between two devices when we have two different paths. Let's say, think about like your Google Maps. So in your Google Map example, let's say you open your Google Maps on your phone and you search for Walmart. So when you search for Walmart, there are conditions that it has to take into consideration which one is the best path. So one is like closest Walmart, right? And then in terms of even if it's closest, it has to be shortest time, right? Sometimes a Walmart may be closer, but it has a traffic jam issue, so it might be bigger, right? So that's why it might route to a different Walmart. And the next one is like avoiding tolls. Let's say you want to avoid the tolls. Next thing, it could be, having consideration like, what else? I would say maybe you're looking for a specific product in the Walmart. Maybe you're looking for carrots. Okay. Looking for whether that Walmart has a product or not, you can search for it. So there are different conditions to select which Walmart you want to go, right? So similarly, in the networking path, let's say you wanted to go to destination. Let's say you wanted to go to 10.0.0.0/24 network. That is the IP address. Let's say this is your destination. To go here, what are your options? There are conditions like best match of destination. We call it as longest prefix match. We will discuss that more later. And then there is a condition of AD value. And there is a condition of metric. There's a condition of equal cost. So these are all networking conditions. Similarly, like your Google Map conditions, there are also network conditions that we will discuss with different routing protocols, the routing fundamentals. That is discussed in the routing fundamentals. On day 6, we will talk about dynamic routing protocols, meaning like, let's say to go to this Walmart in the same example, we can also talk about whether you want to go to Walmart using like walking or like using bicycle, or you can use like a car, or you can go on a public transportation like metro. But these are options that can be done to go to the Walmart, right? Similarly, in routing, there are different routing protocols. You can use a routing protocol like static routing. You can use protocols like RIP, OSPF, EIGRP. Just like your modes of transportation, in networking also there are different routing protocols. Like, we will discuss about OSPF, RIP, EIGRP. That all will be discussed in those classes. Like how do we want to achieve that connection by using these routing protocols? We will talk in detail about what is a OSPF and how it is used. Similarly, EIGRP, we will discuss more on that. And day 9 and day 10 is all about ACLs. ACLs are nothing but access control lists. So this is like controlling the communication between the networks. Meaning, let's take an example. Let's say there is a corporate office. inside this office, you have multiple teams. Let's pick 4 teams. The team A is HR, team B is like accounts, payroll, and then maybe IT. Now we don't want the IT users to communicate with. We don't want the IT users to communicate with the payroll guys. This communication have to be blocked. So ACL is nothing but access control list where you can put permit or deny statements on the interfaces of a network device, whether you wanted to allow the traffic or deny the traffic. It's just like a security control in play, whether you wanted to allow the IP address to go out or come in. It's like, think about like having a security wall for your perimeter of the house, and you have a gatekeeper sitting there and allowing the persons that are only eligible to come in, and they log who is coming and who is going out of the house with a security gate in play. Similarly, ACL is also does the same thing on the router on your layer 3 device. When I mean a router, it's when I mean a layer 3 device, it's called router. A router will have an ACL. The ACL will control the packets going out and coming in, just like the gatekeeper is controlling the persons going out and coming in. Okay, are you guys following so far?
Yes, sir.
Yes.
Yes.
Yes, sir.
Okay, so here with the help of the ACL, we can segregate the users, we can segregate the departments, and then we can control the two-way communication between one department to the other. This way we will have that control of who can communicate with whom in the network. That is about the ACL. So that's so far we have gone through day 10. So, I'm coming to week 3 and week 4. In the week 3, we have concepts like network address translation. Just like you know, a translator, right? In Google, there is a concept of translator. If you put a language inside your Google, it will give you a translated other language, depends on your destined language. It acts as a translator between one language to the other language. Think about like, you know, I say hi or hello in English, that will be hola in Spanish, right? So there is a translation going on between two different languages. Similarly, in networking also, there is a translator or network address translation where it can help us to have that translation going on. Why is this translation really required? Let's say we have a private network. Let's say I have my sitting in my house. So my house is nothing but my private network. And then I wanted to communicate something over the internet, meaning like I wanted to do some shopping in Amazon.com. Okay, so this is Amazon company and Amazon servers are there. I'm trying to go to Amazon.com website. Amazon servers. So what I will do, I will definitely open my PC or my mobile and I'll go to the browser and I do HTTPS www.amazon.com. Right? So I do this. So now my private IP address, meaning like my private network IP address, will be going out to the internet to go to Amazon services, right? To view this website, my private network has to go out of my network and go to the Amazon. Here there should be a gateway which is translating my private network to the public network, because Amazon should know that I'm coming from a known public IP to accept that connection and send the response back. So to make communication outside of my network, I should be having a translator in play from my private to the public network so that I can communicate something outside of the internet. So in every house, whatever the devices that you use will have a private IP that is local to your network. But when you're trying to go outside of your network, there should be a translation which is the private to public translation that is used in the networking with the NAT configuration. So we will discuss about how do we configure NAT, what are the different types of NATs and all of that in the day 11 and day 12. Actually, there is a little bit difference in the order. This layer 2 concept should be coming before the NAT as per the course curriculum. So what is VLAN is nothing but, we know about LAN already, right? So LAN is nothing but intercommunication of systems in the same geographical location. That is a local area network. But separating that LAN to multiple subnetworks at a layer 2 domain is called virtual LAN. Meaning, let's take an example. We talked about subnetwork, right? We talked about when we have multiple teams in the company, we are separating the IP addresses into multiple subnetworks. We talked about having a subnet. At the layer 2 level, or at the, when I mean layer 2, when I meant layers, it's all about talking about the OSI model. That is why I'm referring to layer 2 or layer 3, which is, these words are interchangeable because of the terminologies we use in the networking. So when I mean layer 2, consider that I'm talking about OSI layer model that we're going to discuss in the tomorrow class. But at a layer 2 mean like a switching layer, when we are separating multiple customers at their switching level, then we are talking about as VLAN. So to explain that better, let's talk about a small network. Let's say this is a company. Let's call this company as CCIE core. Okay, there is a company. Inside this company, there are different subnetworks, right? We talked about having subnetwork A, subnetwork B, subnetwork C, subnetwork D, right? So in this subnetwork, let's say this is called as team A, team B, team C. Now these are all subnetworks. This is whole like network. This is a big network. Inside that there are 4 subnetworks, team A, B, C, and D. But now I want more granularity inside the team A, right? So now I'm going to separate team A into multiple smaller teams, and those are called VLANs. If you consider this as a complete network, you can separate them into, this is LAN, and inside that LAN we have separate smaller subgroups. Those are called VLANs, which are virtual LANs. So if you are separating a big network into multiple smaller subnetworks, inside the subnetworks you can separate them into VLANs at a layer 2. So that's how we are getting more granularity inside the same domain as well. We are mapping and we are making that separation at a VLAN level. Okay, is that clear?
Yes.
Okay. So on day 15 and day 16, it's about spanning tree. Spanning tree protocol is avoiding the loops in the network. Meaning, to make it simple, it's like having a looped connections in the network. So let's say there is connection A. Okay, let's take I take 3 places, maybe Atlanta, then I take Virginia, and then I take Texas, right? So if I'm trying to go to something called maybe let's say I'm trying to go to Seattle, okay? So I'm in Texas, I'm trying to go to Seattle. So from Texas, it's pointing to Atlanta. From Atlanta, it's pointing to Virginia, and Virginia, it's pointing to Texas back. But I was never going to the Seattle because there is no connection here, but there is a loop in the network here between these 3 cities, right? So eventually the packet is looping, the route is looping between them, but I'm never going to my destination. So to avoid this kind of looped scenarios in the network, the spanning tree will be used. So spanning tree will use concepts like BPDU, exchange with direction of root bridge to select the best path. That we will discuss in terms of having the HTTP configuration and troubleshooting. And we'll discuss about more on, what is a root bridge, what are the states of the root, what are the states of the spanning tree, what are the flavors of the spanning tree, what are the advancements in each flavor of the spanning tree. We'll discuss more on day 16 and day 17. Okay. Any questions? Okay, so first off, sorry. No questions. Okay, got it. So inter-VLAN routing is nothing but, we know about VLANs, right? I talked about creating sub networks. Inside that, we can give more number of smaller domains or smaller separations. That can be done with the VLAN. But if we wanted to make one VLAN to communicate with the other VLAN, there have to be inter-VLAN routing that we will discuss in the day 17. And day 18, day 19, and day 20 are the first hop redundancy protocols. Meaning, like, let's say, I'm sitting in my house again. I have one. Okay, I'm sitting in my house and I'm trying to go to maybe this time I'm trying to go to facebook.com. Okay. So what is the general connection in my house? So in a general connection of my house, so in my general connection of my house, I will be having a PC that will be connected to a router in the house with a Wi-Fi connected. That will be pointed to the outside and then go out to the facebook.com, right? But what if my router inside the house dies? Let's say the router is powered off. I don't have any redundancy, right? Because my primary device to let me go to the internet is down. So now I should be having some sort of redundancy, like highly available networks should have a redundancy. Like if the primary router fails, there should be a secondary path to go out to the internet, right? So if one path goes down at the gateway level, we should be having another path in corporate networks, not in our house. In our house, we are okay to have a downtime. We are okay to have some sort of issue with our router. If it's go down, we will reboot it. and then we'll come back to it and make sure that it works fine, or we'll call a technician. It's okay to lose some time in the some time of internet in the house because it's not business impacting, or it's not giving any production for us, or it's not running any business out of it. But let's say you are in a Macy's, or let's say you are in a clothes store like JCPenney or Macy's. Let's say you are standing in the counter, and let's say that laptop or that PC lost the internet connection. So every person in the line have to, get the billing done and then go out of the store. But if the network is down, how can they pay the bills, right? It is important for a business to maintain that high availability. If the primary internet service provider go down, there should be a secondary provider, and that provider gateway should be non-user impacting. So that can be achieved by using these first hop redundancy protocols. If the primary go down, the secondary will take over the path in terms of the redundancy. So we will talk about that. We will talk more about that in terms of providing the redundancy between the gateway 1 and gateway 2. Any questions?
No, sir.
Yeah, so that's how on a high level it looks like. So to make it summary, what we discussed. So we will talk about how we interconnect networks. We will talk about how do we get the best practices out of network in terms of having that redundancy, having that failover. We will talk about how to separate the networks with subnetworks. We will talk about how to provide more granularity with VLANs. We will talk about how to control the packets with ACLs. We will talk about how we translate the IP addresses from private to public with network address translations. We will talk about, how do we apply the the failover mechanism with first hop redundancy protocols. We will talk about the dynamic routing protocols like OSPF, EIGRP, and we will talk about the routing fundamentals, or what are the routing criterions. And from there, we will talk about other tools like IP services. We will talk about how do we do some sort of automation of these services that we do on the remaining classes. And we'll add here and there better security with port security and all. So this is the overall motto of the class and how the class looks like. I mean, how do we go on this course? So this will teach you the fundamentals. This will give you a path of understanding of terminologies of what we do and how we do and why are we doing on this way. So that is my my aim on this course, that to make you understand the basics and fundamentals of the networking course. Any questions, guys?
No.
Okay, let me see how much you got from this class then. Vaishnavi, can you tell me why do we need OSI model? Vaishnavi? Okay, Vijay Ramarao, can you tell me why do we need OSI model?
One second, sir.
Venkat, why do we need OSI model?
Sir, it has like layers, the transportation layer, network layer, to transfer data. I mean, it has 7 layers. OSLA, open system interconnection.
No, I'm asking why do we need OSI model? Don't tell me by Googling an answer. Tell me what I discussed in the class. Gopinath, why do we need OSI model? Okay, so we need OSI model because we wanted to troubleshoot the network faster and better. As a network engineer, the OSI layer model will be providing the dividing and conquering mechanism. If one layer fails, we know, okay, the problem is dedicated to this layer, and we can make things faster to fix it. If the problem is at the application, we will know, okay, it's an application issue, it's not a network issue. If the problem is something related to the network, it will be on the layer 2 and layer 3. It could be a routing or switching. So the OSI layer model is used to get that simplification of troubleshooting for the engineers in the IT. That is why we need the OSI layer model. Okay. Ambika, can you tell me what is subnetting and why it is used? I want everyone to come out of mute and tell me the answer. Even though if it's wrong, it's okay, but please be collaborative in the class.
Subnetting, because when for big systems, you were for big systems, if they run out of network, they should be able to handle it, because there'll be problems further. You were telling the examples of maces and shopping sites like that. If they're
No, subnetting is like if you have a big company, you wanted to separate them into multiple smaller networks. Let's say you are owning a corporate company, you wanted users to be separate in different networks, like your HR team, your payroll team, like that. You are separating a big network into multiple smaller networks. That's why we need a subnetwork.
okay, what is the concept I was telling then?
The concept
What is
that you're taking is about redundancy on a high level. When we talked about message example, we are talking about having a failover mechanism. If one path goes down, there should be another path for the failover mechanism that can be done with the FHRP, first hop redundancy protocols.
Okay.
Dhyan, what is network address translation? Why it is used?
Ravi, can you repeat it?
What is network address translation? Why it is used?
Like it is, map the multiple addresses for the LAN connectivity
No.
and used for the transfer the
Translating the
information.
private IP address to a public IP address is the network address translation. When we have something private and we wanted to communicate over the internet, there have to be a translation between the private IP address to the public IP address. That is NATing.
Okay.
Richa Singh, what is spanning tree and why it is used?
Spanning tree is used for avoid the loops, to loop if you have to go in a it's avoid to loop the loops. Yeah,
that is correct. So when there is a loop in the network, we will be applying the spanning tree to make sure the spanning tree will avoid that loop to reduce the load on the network. So yes, that is correct. Gayatri, why do we use VLAN in the network?
VLAN, it is local network.
Okay, I mean even LAN is a local network, right? Then what is VLAN?
Yeah. VLAN is where all these local networks are connected.
No. So inside the
More
LAN, if you
sources
wanted
of
to have
LAN,
more granularity.
yeah.
I'm sorry, go ahead.
No, sir, you can go ahead. Just I was like about to tell that. Yeah, I joined late. Inside the LAN, there are like small sources you told. That is VLAN.
Yeah. If you want more granularity in the LAN, we are still more separating them. We are still more dividing them into multiple smaller subnetworks. That is the VLAN. Okay. Pravalika, why do we need inter-VLAN routing?
Inter-VLAN routing is made to communicate and create VLAN tunnels.
Yeah, if we wanted to make from one VLAN to communicate with other VLAN, we need to have the inter-VLAN routing between them. That can be achieved by using a layer 3 device.
Yeah.
Varsha, why do we need FHRP?
Provide the redundancy to the gateway router.
Yeah, so when we have a gateway as the router to leave our company, if the primary gateway fails, there should be a smooth failover with the secondary gateway. So we will take two routers and we have a protocol like FHRP. Inside that we have different types like VRRP, HSRP, GLBP. There are different types in it, different protocols, but the whole idea is to have that failover mechanism going on without user noticing, and it's a smooth failover. Yes, that is correct. Sarab Chandra, what is a dynamic routing protocol?
Sorry, sir, can you repeat the question?
What is a dynamic routing protocol?
It is used to exchange the information, like the routing information between the routers.
Now, if one path fails, there should be a other path that is available. Remember, I gave an example of going to Walmart. If one path is busy, your Google map will automatically point to a different path. Let's say you miss an exit. It will automatically reroute you dynamically. You don't have to reselect your destination. That dynamic mechanism is done with the dynamic routing protocols. If your primary path fails, it will automatically adjust to your secondary path.
Secondary path, okay.
Right? So yeah, guys, so you got the idea now how the class will be. It will be an interactive session. I'll explain the topic. I will see how much you got from it. We will summarize the class. We will try to do some labs to make understanding like on packet tracer. And yeah, so this is how the course will be. From tomorrow, we will start the class. I wanted to thank you for joining today. If you have any questions, you can ask, or we are good for today. Thank you so much for joining.
Thank you.
Thank you, sir.
Right, thank you, guys.
Thank you, sir. Thank you, sir.
Excuse me.